So let's get started. Last 1.5 hour session for today. After we covered some general stuff in the first one, then gRPC in the second one, then SignalR in the third one, and now we are going to talk about the fourth one that we have in our agenda, and that's primarily OData. One thing came to my mind. I promised you to tell you where you can find the Go sample if you are interested in. I am not aware of any Go sample concerning SignalR in Microsoft's documentation, so this sample is somewhat unique if you are interested in. You can find it in this repository. There I gather some generic Go samples that I typically use during trainings or workshops or demos and so on. And here you can find this example. So if you are interested in, feel free to either take a photo now or just Google it or take a look at the video. We now have it recorded. So this is one thing that I promised you but didn't deliver yet, so now I delivered it. Any questions that came up during the break? Anything where you would say, we have to recap that, something that I didn't describe very well that you would like to repeat? Good? Nice. Good. So let's talk about the third one, OData. Let me start by telling you a story about my personal relationship with OData. It's a kind of love and hate relationship. 10 years ago, when Karen and I founded our current company, Software Architects, we were thinking about building a component of the shelf software as a service solution in the Azure cloud. And we wanted to make the solution something that we really know how to do it. And we have been building CRUD-oriented, business-oriented, data-driven web applications for many, many years now. So we know how to display data, we know how to enter data, how to do reporting, how to do workflows, how to import data, export data. We know how to handle data. And therefore, we decided to build a platform as, let's say, rapid application development system with which we are pretty fast in building such CRUD applications, and then we want to add some specifics from application to application. That worked out pretty well, and we had the typical problem that we have a client. In our case, it's primarily web clients, and then we have a database backend. In our case, we are not that large. Our company is small. We are the builders of a single microservice, so we rarely structure our own applications into multiple microservices because we are simply too small. So we have a kind of rather close relationship between the client and the database. Typical stuff that we have to do is display some data in a grid, make this grid configurable, offer powerful filtering mechanisms, let the user do sorting and looking up data, let the user do some grouping with some intermediate sums and things like that. Let's apply some business logic, like for instance, permission checks, and do some calculations like exchange rate conversion and things like that. And let the user edit the data, let the user create some reports from this data, let the user export this data to Excel, import the data from Excel. This is what we do every single day. This is what our users love our applications for. It's kind of boring, CRUD applications, but it pays our bills. And I know many, many, many companies who have exactly the same problem. They are building that over and over again. And OData has been built with exactly those kind of applications in the background. Let's quickly take a look at where OData lives, odata.org. And in odata.org, it's a standard. It's an ISO standard for building a RESTful web API for data-driven applications. And if we take a look at developers, then we have the documentation, and then we can, for instance, take a look at the let's say URL conventions, let's put it that way, and then let's take a look at who is primarily working on this standard, and now many things become clearer. The driving force behind OData has been and is Microsoft and SAP. So what kind of applications do Microsoft and SAP build where OData could be of value. I'm a strong believer in, if I take a look at the technology, I take a look at who built it, what kind of applications did they build, what kind of problems were they looking a solution for. And in my case, I thought about, okay, what do they build? Think of products like SharePoint. What can you do with SharePoint? Well, listing a bunch of data rows, displaying a grid, enter this data, sounds much like the thing that we do. What does SAP? It's primarily ERP systems, so a lot of CRUD. And therefore, we have to understand that OData has been built for exactly that. CRUD applications, data-driven applications with a powerful query-enabled backend powerful query-enabled database in the backend, and a client that needs a certain level of flexibility. That is what OData has been built for. Now let's first take a look what this OData gives us. We can stay, I think, in this, yes, we can stay in this document. I will zoom in a little bit so you see it better. And I am looking for this one. No, I'm looking for a certain sample. Please bear with me. I will find it. Yep. Yeah. To understand OData, the basic principles of OData, I think it's enough to take a look at these examples. I would like to draw your attention on certain pieces of information here. See that one? If you understand that one, you understand 75% of OData. Imagine you have this situation where you have products in a database, NoSQL or SQL database, and you would like to enable the client, can be a web client, can be a full client, whatever client it is, to send queries to this data store and respond. You can put it that way. OData is a kind of SQL for the web. So they invented a defined and standardized operator, which is, for instance, called $filter, where you can apply a certain expression. It's an expression language similar to expressions that you could put into a where clause of a SQL statement. But this is RESTful. It's designed with RESTful principles in mind. You see, we are addressing the, let's say, tables, if you have a database, using the URL. We are specifying parameters using query parameters. We are using the HTTP verbs, get for reading data, post for inserting data, put patch for updating data, and delete for deleting data. So this is really REST. And this is the idea behind that. Imagine that you could buy a data grid out of the box that understands this standard, that understands OData. You could just point it to such a table and say, this is products, please give me all that the user might want in order to take a look at products and maintain products. And because it is a standard, this data grid can take away a lot of the development work from you. It could do query building automatically, bless you. It could do sorting, server-side sorting, filtering, server-side joining and all this stuff out of the box without you having to do anything. The only thing you have to implement is a server supporting something like this, translating something like this into a query language like SQL or your MongoDB or whatever you have in the background. Get the idea? That's the basic idea of OData. Let's take a closer look at what OData can do in terms of query language. Is it exactly as powerful as SQL? No, it is not. But it is very powerful to a certain degree. So the first thing that we can do is, I already told you that, so let's zoom in a little bit, is filtering. So if you ask yourself, okay, can it do and, or, not, equal, greater, equal? Yes. The answer to all these things is yes. Does it support data types like numbers and dates and so on? Yes. The answer to all these questions is yes. Expand is querying. But the difference between SQL joins and did I say query? Is joining. Sorry. Expand is joining. The difference between SQL joins and OData joins is that the expand clause goes across defined ways. It's in an object-oriented way. It's the reference between one class to the other class. A product with associated orders. An order with an associated customer foreign keys in databases. Expand is essentially navigating across foreign keys. But you cannot freely navigate between any kind of joins, but you have to follow given pathways, given foreign keys. Let's take a look at the expand clause, what we can do with that. Here you have two very simple expand clause. Give me a list of products, and for each product, include the category. This single query, this capability of the OData standard, solves a lot of problems. Imagine you would like to display all the products with their category. What would you do with a classical RESTful web API? You would say, give me all products, and then for each product you would do an HTTP request. Maybe if you implement it naively, you would do a separate HTTP request getting the category for each product. If you are a little bit smarter, then you might recognize that you have already queried a certain category and you only query distinct categories. But at the end of the day, that's a lot of wasted time, because it should be possible from the client side to immediately request the products with the joined categories. And you get back a single JSON document with all the data in it. And that's exactly what this first thing does. And it goes through down to the database if you want. We'll see that. But it is much more powerful. You see, give me a list of customers, but this time I am joining across a one-to-many relationship. I say, give me a list of customers, and for each customer, give me a list of addresses, and from all these addresses, I'm only interested in the field country. Get the idea? That's a non-trivial query that we make here. And the client can decide to do so. If the client developer needs that for whatever reason, he doesn't need to go to the server developers and say, would you please create a new web API call for me? No, he can decide on his own that he wants and needs to do that. You can do restricted joins. Give me a list of categories, and for every category, give me a list of products, but inside of these products, give me only the products where discontinued date equals null, which are not discontinued. Get the idea? This is a non-trivial join, and it is a single HTTP request, and we will immediately get back all the data in a single HTTP response in a single JSON document. Get it? Okay, I think you can imagine what you can do with that. By the way, you can query recursive structures and things like that, so it's really powerful. Select. I don't need to describe select, it's a projection. So you can say, I need the customers, but only those two columns. Think of combo box, only primary key and description. Very powerful. There's no need to download hundreds of columns if you just need two. Get the idea? Yes, you have an expression language where you can do calculations. Things like addition, multiplication, division, and things like that. String operations, datetime operations. You can cut something out of a string and only return a substring from that. You never need to translate the whole data across the network. You can do all the calculation on the server, and you send the expression to the server. You give it the definition of how it should calculate these columns. Order by is clear, top and skip is clear, count might be clear, it will immediately return the total number of rows. So you can do some paging more efficiently, you can do some server-side paging. For instance, if you buy a powerful grid today that supports OData, and there are multiple vendors who do that, you can do server-side virtual scrolling out of the box without you having to write a single line of code. It just works. Get it? Good. Let's take a look in practice how this looks like. And one of the nicest things that I can show you here is a nice little tool which is called XOData. Oops, that's the wrong one. XOData, not XData. This is what I wanted to click on. Good. It's just a demo. And here with this Data Explorer, we can, for instance, say, well, I would like to see a list of products. And here, where I want to define that the description the description contains, let's say contains. Where is contains? Here is contains. Contains milk. Yeah. If we do something like this, we see the query which says top 20 substring off description and milk equals true. I think you get the idea. That's typical. That looks like the applications that we build every single day. Some customers would like to filter like that, would like to filter like that. I need a way to store these filtered queries. I can simply store the OData query string. And this is what this stuff does. Get the idea, approximately? Now, of course, I can click on get data, and I will get a lot of data. And if I now only need the description and the price, then I can go to columns and say I would like to have the price and the, where do we have the description? I think it was, here is the description. Click on it, and immediately the data that is returned is reduced significantly. Now, is OData just about querying? No. OData is about querying and writing data. It's about serializing and deserializing business-oriented data, so it supports a much more powerful data type system than just REST. Things like decimal numbers, things like integers, things like dates, and so on, they are very well defined in OData. It has been built with business applications in background. You can insert data with post. You can update data with put and patch. Partial updates and full updates are supported. You can delete data. The OData standard defines a standard for sending so-called batched transactions. So you can send multiple write operations with a single HTTP request and, for instance, execute all these write operations in a single database transactions. Yes, you heard me correctly. You can send multiple writes through an HTTP web service using atom transactions, ACID transactions of the database in an HTTP REST API. Not across HTTP requests. Inside a single HTTP request. And you don't need to write any code for that. So that's the standard. The standard comes with something else, which is pretty powerful. If we take a look at odata.org again and look for reference services, then we will, for instance, see, let's take a look at this trip pin service. It's available publicly on the internet here. And we can say /$ metadata. Good, here it is. You have to understand that this was invented long before we had Swagger. OData also tried to solve the problem of metadata for RESTful web APIs. At that point in time, the idea was if somebody walks up to a server that speaks OData and knows all these powerful query capabilities, how should the client be able to ask the server, what can you offer? If you are in database development, I grew up with SQL in mind. I know SQL quite well, and so I'm used to doing things like select star from sys.tables or select star from information schema.tables, things like that, just to find out what tables do I have in the database. Anybody is doing that too? So I do that all the time. This is exactly the same, but for OData. So I can ask the database, doesn't need to be a database, but it is an OData server, what do you do? What can you do? And this is at the opposite end of the equation compared to gRPC. This is just REST. So what I get back is an information that tells me, okay, there are a bunch of data types. For instance, there is a person, it has a key is the username, and these and that properties. And by the way, if you have a person, you can immediately navigate to the person's friends, to the best friend, to all the trips that this person had. You can ask for airlines. You can ask for airports, and so on and so on. If I scroll down a little bit, we also find not just data types. Let me see. Yeah, entity type. Here it is. We can also find so-called functions. We can have bound functions and unbound functions. You know what that translates to? Stored functions and stored procedures. We can apply a stored procedure on a table with input parameters, and this can read data or write data. So we can encapsulate business logic, put it into our metadata model to have some operations on the data that we store. This is really pure REST, but over an HTTP protocol. Get the idea? Completely different from gRPC. Something completely different. It goes in the opposite direction if you want. Questions so far? Maybe you have some questions in your mind. What about ... Okay, not yet. I understand. In OData, the standard only covers metadata, querying, and writing data. This is what the standard does. The standard says nothing about how to implement this stuff. You might now take a look at that and also at the dollar filter and so on and ask yourself, well, that sounds good. It would be great if I would have something like this, but how do I get it? I mean, it's like a wish list. For some, it might be a dream of a wish list to have. Well, for me, it would be a dream. I would like to have JSON here instead of XML, but okay, well, I mean, that came up many years ago. So how do we get it? And this is where the story begins to be not as nice as it should be. Because if you ask me, the only reasonable way, if you don't have a lot of resources available, the only reasonable way to get such an OData provider is using .NET. You could implement something like this in Java, you could implement it in JavaScript, you could implement it in C++, it's just a standard and it's just HTTP, but to be honest, it's super complicated to implement. In .NET, and this is the power here, this is why Microsoft and SAP are so strong behind this stuff, the sweet spot is if you have a database, if you have an OR mapper directly in .NET and you can put OData on top of it and let .NET do all the magic. And this is exactly what OData does for many, many companies. So for many companies, now let's put it that way. Take your hat as a software architect to the side and imagine the following situation. You work in an enterprise. You have a database. Don't care if it's Postgres, MySQL, Oracle, SQL Server, or whatever. Then a department head comes to you and says, I need an application for 200 of my employees, and they need to be able to perform some database management tasks, so entering some data, doing some reporting on this database. I need this application as soon as possible, and you don't have a lot of budget. Build it now. Well, in the past, what did people do? They hacked together some two-tier applications with WinForms and WPF because they didn't have the time to build all the services that they need to build. That's the reality. And with OData, you can do something like this. I would like to draw a little bit here. They can send, okay, here I have the database. On top of this database, we put a really nice object relational mapper. On top of this object relational mapper, we put OData. And we hope that our OData query somehow magically can be translated to OData to object relational mapper queries, because that is translated into SQL. And then we offer this service as a REST API. And then down here we have the browser client. And this browser client maybe has some smart grid that understands immediately OData. So we have a nice multiple tier application which follows the RESTful principles exactly as we want it. This can be newest technology. This can be newest technology. We have a little bit of abstraction layer here in the middle. So if we want to rename the tables or do something like this, we can do that here to a certain degree. And that's it. Is it the most beautiful system on earth? No, because you are not hiding all implementation details. To a certain degree, this client gets a glimpse of the database structure because it's somehow linked from here to here. But when I think of many customers where I have to do consulting, then many tell me, we don't want to publish the details of our database. We need a layer of data transfer objects here in the middle, and then I compare the DTOs with their database, and in 99.9 cases, it's the same. Oops. They have maybe 1 or 2 places where they really want to differ, but to be honest, that's in many cases just, yeah, a side event. It's not in the core of their application. So if you have applications like that, and you want to get as fast as possible to such an application with the power of OData that you have seen here, then .NET and OData really shines. Because this, in .NET, is called Entity Framework. It's very powerful to translate it to any database that you want, including NoSQL databases, since recently. OData comes out of the box. There is a C# implementation which automatically can translate any of these queries that you have seen here directly to OData, to Entity Framework. And this, as I told you, comes from vendors like, for instance, Progress Telerik. We are using Progress Telerik, the grid, and it knows OData out of the box. Get the idea? So with that, let's take a look at some code so that we understand what's really behind the scenes, if that is true what I tell you. So the first sample that I would like to walk you through is a sample with a single file. I consciously made it super simple in order to make it super easy to follow along. The first thing that I have to tell you is that it is not .NET Core 3.0. OData, the current implementation of OData, does not implement ASP.NET Core 3. It's not possible. It will hopefully come in the next few months. There are open GitHub issues with a long discussion history because people want to have this with .NET Core 3, but the team is suffering of the 24-hour syndrome. They will need more than 24 hours per day. If you want to do that, then you can just import ASP.NET or OData. That's all you need. Then, in the program, you build some classes like this. This could now be a class that is somehow stored in a database or not. I don't care. Then all you need to do is you need to tell the system, add OData, similar to add SignalR, similar to add gRPC. Again, OData and SignalR, they can all live in the same application. And then you say, I would like to enable selecting, filtering, and top clauses up to 50. So this is kind of security mechanism. I can tell which operations are allowed in my OData server. Of course, I can make specific precautions. I can take existing advanced precautions on a per table or per class level, but we'll talk about that later on. And that's it. Then you create an OData controller, this one. You have some kind of data store. In my case, I'm not using a relational database in the first example. I'm just using an in-memory list of T. And that's it. Then you have a one-liner. You return it something that understands queries. Normally, now everything is clear. But in this room, I understand that many people don't know C# very well. You have to understand what a queryable is in order to understand how OData works. Who does not know what a C# queryable is? Okay, most of you. Let me quickly demonstrate what that means. Really quickly. That's necessary, otherwise you don't understand how this stuff works, what the idea is. You don't need to follow along. Now, you probably know this one. This is a lambda expression. A lambda expression where I say I have a function that gets 2 integers as parameters, x and y, and will return an integer, the result. And I just say x plus y plus 42, whatever. If I write something like that, and I put a breakpoint here, and I press F5, if I hover over F, will be done in a second, then the system will tell me, I want to see what F is. Okay. Let me try it again. The Visual Studio warning was overlaying my debugger watch point. So now, if I go here, then you see, it can only tell me at runtime, hey Rainer, this is a function, it gets 2 integers and it will return an integer. At runtime, we have no real idea what the business logic is that is contained in this function. It's intermediate language, and at the end of the day, it's machine language. Can we translate that into some kind of SQL? No, of course not, because then we would have to inspect machine language at runtime and try to guess from looking at machine language what this thing could do. Doesn't make sense, doesn't work. So, in C#, there is something which is called an expression tree. It works like this. Let's give it a using. Come on, exactly. And run it again. The second syntax looks nearly identical to the first one, but the big difference, good, is that we now why can't I see my result? Because I didn't change the startup project. Oh my God, it's a long day. I always started the wrong application. So this was still true. Yes, just a method, just assembler code. But if we take a look at the expression here, we will see, can you see that? No, you cannot really see that, so I have to keep it like this. We see that at runtime, the debugger somehow can figure out what the business logic is here. How does he do it? Well, this is, if you are into compiler building, this is an abstract syntax tree of the C# language made available at runtime. So by assigning it to an expression of t, we can take a look at the body and we will see that this is an addition. You see that? On the left-hand side, we have an expression x plus y. On the right-hand side, we have a constant, which is 42. So what we essentially get, we get a possibility to reflect into the C# code at runtime. That's the idea of expression trees. And a queryable in C# is something that can take in such an expression tree, convert it to any language that it would like, and return a result based on this translation. So in our case, it will take our function, can translate it into SQL, send it to the database, run it there, and return the result as if it would come from C#, but in reality somebody else did it. You get the idea? That's the idea of iQueryable. And that's the magic why this stuff really works. Because if we take a look at here, we are turning our list of t into a queryable, into something that can accept any kind of expression tree and evaluate this stuff. You get what I mean? So what we essentially get from OData is we get a URL. This URL is then turned into an expression tree. So a kind of reflection of this URL, a kind of document object model of our query. This expression tree is then given to Entity Framework, which turns it into SQL or any other query language, and this is then executed against the database. Get the idea? And all we need to do is we need to provide a queryable. As long as we have a queryable, everything is fine. It doesn't matter if it's in memory, doesn't matter if it's a relational database, doesn't matter if it's no SQL database. As long as we have a queryable, everything is fine. Everything else is done by OData. You get the idea? Up until now, approximately? Okay. So this is simple. If we go in here, run not the console app, but this basic application, Let's run it. And you will see it immediately, how it works. So you see, here we have a customer endpoint, API OData customers. I think it was put like that. And we will get back a result. Zoom in a little bit. You see, John Doe and Foo Bar. And that's exactly what we had here. And it's really nice URL. You get the context information. We can reflect the data structure. So we get a link to the metadata. From the metadata, we can find the navigation properties. If we have a customer, how do we come to the orders? If we have an order, how do we get to the order details? If we have the order detail, how do we get to the product? I think you get the idea. That's really very nice REST in just, I don't know, 10 lines of code or so. And without doing anything, I can immediately do something like $filter equals to, first name John, $filter equals to first name equals John. And if we do that, we only get John. You see that? Did we have to program that? No, because OData does it behind the scenes fully automatically. Get the idea? Let's go one step further. Let's use a real-world application. A real-world application where I was creating a more complex data model. For instance, this one. I created a customer. This customer has a bunch of columns. These columns have some attributes like required, max length, and so on. We have products. We have an order header. We have order details, as you can see it here. And that's it. That's our database. Then I've put a so-called entity framework data context on top of it. The only thing that I said is, hey, entity framework, I have a customer table, I have a product table, I have an order header table, and I have an order detail table. That's all I had to do. And that's the only thing that I had to do. Now I can immediately do all the querying that you have seen directly down to the database. Let me show you what I mean. Let's run this guy. And I've prepared some demo HTTP requests for you. Let's wait until it comes up. It accesses a local SQL server from my database, from my computer. And the first thing is that I want to say, hey, OData, what can you offer? I'm querying the $metadata endpoint. And you see, without me writing any code, I can reflect on my C# classes, meaning my database structure, and I get back the tables, I get back the names of the columns, I get back the navigation properties, and so on and so on. Next one, I can now say, give me a list of customers, but only those customers which are in Austria. Country ISO code equals AT. Let's run this guy. And I will get back 2 rows. Now you can believe me or not, but I can show you how the system did this query. I've added some logging here, and I would like you to take a look at this one. As you can see here, this is the select statement that was generated from my OData request. So the important point that I would like you to take a look at is this line. I specified the query in my URL, and the $filter clause was automatically parsed by OData, put into an expression tree. This expression tree was then put into Entity Framework. Entity Framework has built this query. So the filter expression was injected into the SQL, and I didn't have to write any code for that. So I use the database for what it is really good. Filtering data, grouping data, sorting data. This is what the database can do really, really good. And this came from the URL. The client can now ask for certain data with filters and things like that, and these filters go through to the database. I never load all the data in memory. Do you get the idea? Is this the solution for everything? Absolutely not. But for a solution where you have a powerful database in the background, it's really good. Let's continue. That's of course not the only thing that we can do. Expanding. Expand orders. Let's query that one. Here you see, we now get in a single HTTP request, we get the company data and we get an array of orders. So that solves the problem of having a nested loop of HTTP requests. Give me all the customers, and for each customer, give me a list of all the orders. I've seen many companies that had this problem doing what? Starting to implement their custom GraphQL projects. They have started GraphQL and they have built powerful codes in the background where you do this nested loop query somehow in your GraphQL implementation so that you don't need to send HTTP requests from the client to the server, but they did, again, issue a lot of single SQL statements to the database. And then the database said, nope, I will not answer quickly because if you send me tens of thousands of small SQL statements, that is not what I have been built for. As a relational database, I want to have complex queries. This is what I was built for. I know how to join data. I know how to do intelligent, how to calculate hashes and to do inner joins and nested loop joins and parallelize everything. And this is exactly what happens with OData. I think you get the idea that this one is generating a single SQL query by the OR mapper instead of having the one-to-n problem that we have in that I described, right? Do you understand it without me showing it? Okay, I don't know why I can't access the order details now. I will look that up. Additionally, I can hide some more complex business logic in functions in my C# code. And I would like to focus on that because that is much more interesting. Let's take a look, for instance, at the orders controller here. Because in this controller, it's in the customers controller here. What I can do is I can add, you see, business logic in C# and return it from an OData controller. So this ordered bike, what does it do? It gives me a list of customers where each customer has at least one order with at least one order detail from a product in the category bike. That's a non-trivial subselect that we do here. You understand what I mean? I don't want the user down there to specify a really complex OData query. I created a so-called function. This is what I told you, like a stored procedure or a stored function where I can isolate some business logic, give it a name, and then provide that at an endpoint for the client to query. You get the idea? Now let's see if I at least can, yes, I can show you that one. This one works. So you see, this is the SQL statement that we are generating. The end user just had to specify, give me a list of ordered bikes. Bikes that are customers that ordered a bike. You see, it's linked to the customers. So I only get customer data, but with a complex filter expression that I told you before. And this is all written directly to SQL in here. The magic of OData goes one step further because what we do here, we are returning a pre-filtered queryable. So what we can do inside our client, we can even go one step further and add a filter condition on top of the pre-filtered data. So I say, give me all the customers who have ordered a bike, but I'm only interested in customers from Switzerland. You get the idea? Let's take a look at that one. Send the request. It worked. We get the Swiss customer, and you see, OData is powerful enough to recognize that and to add the filter on top of the pre-filtered data. Get the idea? This might be something that you don't use every day, but you often use something similar every day. Let's stop this application for a second. And let me show you in the orders controller what you can do here. So for instance, here we have the orders that we want to give back. What if we would like to, I think I have an example in the customers controller, don't I? Yes, here it's better. What if I don't want to return all customers? I could do something like this. If maybe I have an open ID authentication server in front, I can say if user claim country equals Switzerland. I would like to pre-filter if the customer is from Switzerland that he only gets data from Switzerland. You get the idea? So with that I can do, let's do something like this. I can do something like this and say var result equals db.customers. And then say result equals to result.where customer.country ISO code equals Switzerland. Something like this, and then return the result here. So in this case, I can do security mechanisms. I can pre-filter the data conditionally depending on the claims in the tokens of the user. So if a user goes to my service, I can take a look in the token. If the user is no administrator and so on, I can return pre-filtered data, and this will be part of the SQL query that OData generates. You get the idea? And then the user can put his filters on top of my filters that I have created because of security reasons. This is something that is very, very common. Conditional pre-filtering based on access permissions. You know what I mean? If you just think of, with your existing technologies, how you would solve such a problem, having a configurable querying endpoint with all the security features and so on, it typically will take a while until you have implemented such a project. Of course, because it's hard to implement. And this is where the sweet spot of OData is. Questions so far? Yeah?
How would you compare OData to GraphQL besides the fact that OData is more aligned with the RESTful strength?
Yeah, very good question. How do we compare OData to GraphQL? OData, if you just ask for OData, the standard OData, then a very important point of distinction is that OData does not contain any rules for how to implement an OData provider. OData is just a specification sitting on top of the RESTful Web API design principles and making clearer guidelines for how to do filtering, sorting, and so on, how to express a data model, $metadata, and how to write data. This is what OData does, full stop. In GraphQL, it's different. GraphQL comes with a query specification, but GraphQL also contains a guideline or a reference implementation for how GraphQL really works. This is what GraphQL does. So OData on itself, a big distinction, no implementation, just standard, just protocol. That's the first important distinction. Second important distinction, OData has been designed and with the reference implementation in C#, built with relational databases in mind. GraphQL not. If you think of how GraphQL, does everybody know how a GraphQL query looks like? No? Some say yes, some say no. Let me quickly show you one. So that we are all speaking of the same, I will take, where is it? This is a slide deck of my good friend Christian Schwentner, who will do the GraphQL talk here at this conference. But he was so nice to share at least parts of his slides with me. So I will not show you the whole thing, but I can quickly show you a typical query. Where do we have a query? GraphQL features. This is a typical GraphQL query. Give me the first two books. I need to have the title of the book and join the author and give me a first name and a last name. And where GraphQL really shines, or what GraphQL does by default, without you doing a lot of tricks, it will assume that title is stored in a certain microservice and will query that microservice. And then in a nested loop, it will go through the first name of the author and look in a different microservice, passing in the book ID and asks this microservice, give me the first name of the author of this book. And then it will take the next column, ask a third microservice for the last name of the book, again in a nested loop. Of course, you can do tricks. You know that first name and last name are in the same microservice, then you can maybe reduce the number of calls. But still, it does exactly that. It goes through all the result columns, and for each result column, it asks a microservice. It asks your code without any tricks. Christian will show you tricks. So you can do things like that. But it has never been built with a SQL database in mind, where you can easily generate a query. In that case, it's a very simple query. Select title, first name, last name from books, inner join authors, blah. That's all. This is what OData can really do. Do you understand what I mean? So GraphQL is powerful if you have separated your data into microservices, but not that much with OData. I can show you that OData can also do something like this, but again, not easily. You have to do a lot of tricks.
Yeah, I would just say, because on the protocol level, this one is relatively easily translated into OData by just using the expand to the author and using the select for the title and then the first name and the last name of the author. The implementation is a different thing, but at least this kind of query is where the two protocols are quite similar.
Yeah, the protocols.
There are other things in there where, of course, there's bigger differences, but this is
Yeah.
actually quite a nice one where you can do a cross-translation. Yeah?
But only on a protocol level. But implementing this, if you have the three microservices in OData, it will take you months. It will take you months of work to implement that. I have built a custom OData provider for our own implementation, and it took me months to come up with a real powerful solution where you can translate that into microservice calls in the backend. It's really hard, and I will show you that in a second. Not the whole thing, just a glimpse of how you could do that. But it was a very good question, and I hope I could answer it. So if you need an aggregation solution over microservices, GraphQL is your thing. If you need a front end for a relational or NoSQL database, then you can take a look in OData.
I think what got me confused is really the distinction between the protocol level and the implementation.
Exactly, and I hope we could work that out. Yes?
Really familiar about,
Yeah, exactly. If you just take a look at the protocols, they look pretty similar, but they were invented with two very different companies and problems in mind. Microsoft and SAP building database-oriented business applications. This stuff coming from Facebook. I'm not a developer of Facebook, but I can just assume that Facebook has quite a few microservices in the backend, and they just need to aggregate data from multiple microservices into a single backend for front-end call. And this is where GraphQL comes from.
Having said that, is OData strictly limited to one database source?
Ha! Good question. Let's take a look at that. What's happening behind the scenes? And I hope you are ready for a little bit deep dive into syntax trees and things like that. No, it's not going to be as complicated. I've built a small example because I get this question so often that doesn't have a database in the background. In this case, let me quickly show you what this application does, okay? So I start it, and I start my file explorer, and here I also open it with Visual Studio Code. Yes. Server comes up. We'll be here in a second. Maybe I have not stopped my debugger. Yeah, I stopped it here and I stopped it here. Yeah, everything's fine. Should be up in a second. Yes, here it is. Good, good, good. I can ask for a list of customers. This will give me a list of customers. Okay. I can ask for the top 3 customers. I can ask for some metadata, nothing special, and I can also filter. The point is, if I go to this list of customers, take a look at the last names here. See that one? You always get different data, right? This is a sample that has no database in the background at all. It is completely made up with an algorithm, and that is the point. It is possible in OData to say, this is what I'm interested in. Here, I'm not using this stuff up here. Dear OData, give me the syntax tree of the query, and I myself will write any kind of arbitrary C# code to come up with a result. Whatever I do, Harry Potter programming, fairy dust, glass bowl, whatever I do, I somehow have to come up with a result. So with that, I can use OData over an IoT device, reading data from an hardware sensor. I can use OData to query 3 different microservices in the background. I can use OData across multiple databases. I don't care, and OData doesn't care either. It will just give me the query, and it will say, calculate the result and give me the result. You know what I mean? This is what OData does here. And let's take a look at this example, how it works. I will show you that here. Let's get rid of that one. In that case, I have a so-called OData route, which is query enabled, but here I get an interesting parameter. I get OData query options. And this is essentially the syntax tree of the OData query. Are you familiar with the term syntax tree? Anybody not familiar with syntax tree? It's the DOM, the document object model, over the $filter, $top, $order by, and so on. That's essentially what a syntax tree is. It's the result of a lexer and a parser. I will set a breakpoint here and run this query again. Click. Now I can take a look in these options. Let's do that one. And inside of these options, click, I will find, for instance, if I scroll down a little bit, a top clause. And in this top clause, I will see, okay, the user asked me for 3 customers. Why? Because in the OData query I had $top equals 3. Get the idea? We can also take a look in the filter clause. Here is the filter clause. The filter clause contains, here is the filter clause, here, an expression and an item type, and we want to take a look at the expression. The expression has an equal sign in the middle. On the left-hand side, we have a reference to the last name property. On the right-hand side of the equal sign, we have a constant type string of Smith. You get the idea? So we get the parsed OData query string, and now we somehow have to come up with a result. Whatever we do. So we have to translate it, interpret it, whatever we do, and return something. So in my case, I made it pretty simple. In my case, pretty naive, to be honest. I just remember the top clause, and then I take a look at the equals filter, and essentially, I don't want to bore you with the details. I'm doing some random stuff, as you see it here, and I'm generating some random number of customers, completely random, that fit to the query of the customer. Get the idea? But please use your imagination here. Here, you could query downstream microservices. But you would have to take a look in the syntax tree, and you would have to recognize, do we have the expand clause from the books to the author? If yes, I would have to query the microservice. But you have to take a look in the expression tree, in the syntax tree of OData, and interpret it yourself. And that's not simple. That's really not simple. Do you get the idea? So, okay, question.
I look into the expression tree and can do what I want.
Yes.
That much I understood. But still, maybe I'm just not understanding quickly enough. If you just happen to have 2 SQL databases as the source, would there be an easier way than that to access both of them?
Linked tables. Okay. You have to solve this problem on a database level. But you cannot solve it on the level of OData. OData just wants a single queryable. And it translates this into the queryable. So what you are essentially technically asking is, can entity framework handle multiple databases? Well, not transparently. You have to do something in the database to, for instance, create a view which is linked to a different database, then you can do tricks like that. Yeah.
But that would be pragmatic approach to do just that.
If that is okay for you, it's possible. I live in the Azure cloud, and in the Azure cloud, every database is technically its own database cluster, and I cannot do cross-database queries because that would mean I have cross-database cluster queries, and that's not supported. So for me, it's unfortunately not a pragmatic solution. It's simply a no-go. But that's just me. If you have a local database, a local SQL server or whatever that supports this option, that's definitely an option that you could think of. Yeah.
Just as a comment here as well, I think one of the problems that comes up is that OData is so open from the language that someone now could send a request that is doing conditional filters that affect things across the two databases. I think that's the bigger problem. As long as the requests come in, have to be calculated on one of the two databases, you're fine. But if now the client decides to send something that does this conditional part, then you're getting into trouble. Of course, you could still have it in a way that you're throwing an error in that case. You could even try to express it via annotations, that there is some dependency here. But that's where, if you're coming from the GraphQL world, where you're just not offered anything like that, anything you have as a capability, you have to add as an additional parameter into the query, there you simply cannot run into this thing because the client could never send anything that you haven't explicitly defined. But of course, it then also means if you have a lot of things that you're adding, then in GraphQL you keep adding functionality, whereas in OData you don't have that problem. So it's it's two different poles of the similar space.
You're absolutely right. And in OData it's really like Matrix with the blue pill and the red pill. But the inventors of OData, they were used to SQL, select, insert, update, delete. And they loved it. And now they had to have a service in the middle. And suddenly they were missing SQL. So they invented OData because they wanted to have something like SQL because it made them so productive. So if you are in the blue pill, and if you have a single database, and if you have an OR mapper like this, and if you have C#, it's really so nice to live in this OData land. But immediately, if you want to change a single thing in this equation, go from C# to Java, go from a single database to multiple databases or microservices, where you want to query across microservices or things like that, out of a SQL database into a, let's say, more algorithmic generated result, then it starts to become a red pill and you have to dive deep and write a lot of code in order to provide OData. So that's a bit of the drawback here, yeah?
Just one thing, I think I'm not too familiar with the details of it, but in Java you also have Olingo as a library that helps you a lot with getting there, getting closer to it. As I said, I'm not sure how far it really gets you, but at least it helps you with analyzing all the syntax trees and all of these things. Similar to you have.
Thank you for pointing that out. I'm not familiar, as I told you, with Java. Maybe there are libraries which are pretty nice and and will get you there. Having this OData stuff, of course, gives you a lot of really nice stuff that not the basic one, that are a value on its own. So let me quickly start this custom provider again. We could question whether it makes sense to offer our application here, I think it was OData/customers. Okay, let's remove the breakpoint here and continue. Okay, this gives me customers and $metadata. Gives me the metadata. Where do I want to go to? Well, I can start a client, something like Power BI, something like Excel. And nearly all the Microsoft clients, they understand OData, and that gives me an interesting opportunity. If I have my data in OData, I can offer it to my customers via a web API interface. So what I can do, I can, for instance, say, get some data, and guess what? OData feed. I can just go here into Power BI and tell it, here is my OData feed. It will go to this OData feed. In this case, I can access this anonymously, but I could also do some authentication here. I've used two new versions of OData here. Let me show it to you differently here. Let's take this one, Northwind. Better. Same principle. And you see, I immediately get a list of tables from this OData stuff, and I can say, oh, I would need, let's say, some order details, let's put it that way. And I see this data, I can immediately load it into a Power BI. It understands OData, it understands the protocol, it loads some data, and I can, for instance, do something like this and that, and I think you, come on, thank you. And for instance, say, give me the product ID and give me the quantity, for instance, and with that I can build, I'm not a Power BI expert. With this I can build interesting stuff. For instance, product ID should be here. Nice. Now I have some data here and I can drill into it, and I think you get the idea. So because OData is so widely spread, it's pretty old. It's more than 10 years old. It's widely used. It's used in Excel, it's used in Power BI, it's used in many other dashboarding applications. So therefore, OData gives you the possibility to publish your data in a way that many clients can consume without having programmer skills. Get the idea? So I can show you examples where customers of ours, they have built really impressive dashboards based on our own OData provider without us calling a single time, because they took our OData feed and accessed the database. You know what I mean? Of course, we are protecting it because it's just HTTP, so we can use all the reverse proxy stuff and can put a web application firewall in front of it and can do quota management and all this stuff. It's just HTTP. It's fine if the customer are accessing our business logic and data through our OData feed. Do you get the idea? Even if you have OData, even if you have C# and you have a relational database, there are still some disadvantages of OData, unfortunately. Microsoft is using OData a lot, and the part of OData here, so the OData lexer, parser, all this stuff, it is super robust. It is maintained on a very high level by Microsoft. It's nearly always up to date. And why do they do it? Because they have internal customers who are relying on this stuff. Azure is built on top of OData. SharePoint is built on top of OData. Office 365 is built on OData. OData is really at the very heart of all this stuff. But when it comes to this stuff up here, support for entity framework, support for ASP.NET, they are not investing so much money. So you're always a few months behind the latest version of .NET. And that brings some customers to a very difficult decision. They would like to have the functionality of OData, but they don't fully trust Microsoft with OData. Therefore, they look into GraphQL and they see that GraphQL does not give them the functionality that OData gives them. And so you have two options which are not really perfect. If you decide to go for OData, you have to be prepared that you are lagging a little bit behind the latest version of ASP.NET. If your mind is like, okay, now is ASP.NET 3 available, I want to use it now and I want to have OData immediately, that will not work with OData. You have to sit down, relax, and be happy with the fact that support for ASP.NET 3 comes maybe half a year after the launch of ASP.NET Core 3. That's how it goes with OData. I don't want to set expectations too high. That's it. That's the world that we live in if you use OData. Understand what I mean? Would I use OData in a new project where I have a database in the background and would use C#? That's exactly my answer. I can't tell you. If you ask me as a technician, I would say no. It's not reliable enough. They are not investing enough. It's such a cool product, but it's not really fully maintained and really cool technology. But on the other hand, it's so useful. That's exactly the problem. And either you go for technology or you go for functionality, and it's fine for me if it's a little bit older. Yeah, it's a very difficult decision. Very difficult. But I can tell you a lot of my customers are super happy with OData, and they are especially super productive. It depends. Do you get the idea? What this OData stuff is all about? Who would say this is a technology that, independent of the technological problems, would help me in my everyday work if I would have it? I would be interested in. Do you have these problems of CRUD applications on top of databases? Some of you. Okay. Who would say this GraphQL stuff with many microservices aggregating data, this is your problem because you have this 100 microservices and you would like to gather the data together? Okay. Also, some of you. But I saw more hands raised with the OData stuff. That's really typical. I see that very often. Do you have additional questions regarding this OData stuff? Where are the samples? If you would like to take a closer look here, in my samples repository, I have here OData for .NET Core, OData for .NET Core, and here in the middle, it's a little bit outdated because that is .NET Framework, not Core. But if you still live in .NET Framework world, these samples might be helpful for you. So you can go into details. And the second thing that I would like to point out, in my YouTube channel, I have a workshop from one of the API conferences. It's here, part 2 and part 1. And this is more than 3 hours of deep dive into OData. So if you say, okay, that's interesting, I want to learn more. I want to spend more time looking at these samples, at the code, take a look at these 2 videos. There you have over 3 hours of only diving into OData, me writing a lot more ad hoc code and describing the implementation details in more details. But this is only for you if you are really into C#, because this is much stricter towards C#, much more implementation details. Okay? This is what I can give you for OData. Time is flying. And at the end of such a workshop, I always like to look back what I promised you, so that we can recap what we did and think about what was the content of the day. The goal of this workshop was to describe 3 different technologies. 3 different technologies, namely WebSocket with SignalR, OData, and gRPC. I've not shown you slides. We talked conceptually, and I showed you some samples. I gave you the samples on GitHub, and I tried to make it very clear from an architectural and an implementation standpoint what the different workflows are with gRPC, with SignalR, and with OData. Of these 3 technologies, all 3 technologies brings us further than just basic RESTful web API. And my goal was that you leave this workshop and you have a clearer picture in mind for which of my problems should I use what technology. Where are the sweet spot of these technologies? How do they differ in everyday work? And where are the similarities? We looked a little bit to the side in the direction of GraphQL, but I stripped all the details because Christian is going to cover them and I only had 1 day. And we looked a little bit towards message-based communication. We talked about differences with all these technologies and message-based systems like Azure Service Bus, RabbitMQ, and things like that. This was the content of this workshop, and I hope it was interesting for you. If you have further questions, I will not run away immediately. So if you want, come to the front, we can discuss it. I will be the last one to leave this room, so I will stay here until all your questions for today are answered. For everybody else who doesn't have any questions anymore, I would like to thank you for participating in this workshop. I hope it was an interesting day, and I hope to see some of your faces tomorrow in one of my talks. Okay? Enjoy the rest of the API conference, and yeah, see you tomorrow. Thank you very much. Thank you for coming.